In this presentation, we are going to discuss about signed 2's complement representation. This is one of those methods by which signed number can be represented. Earlier we have discussed about signed 1's complement representation and signed magnitude representation. Now let us see the most popular and mostly used representation method, that is 2's complement representation. So before we move to the representation mechanism, first we need to distinguish a very crucial thing, that is the signed 2's complement representation and 2's complement operation. Suppose we are given a question like this. We have a number plus 3 and it is asked what is the 2's complement representation of plus 3. Then what happens? The representation of positive number in 2's complement operation is always positive, because the representation of positive number is same in all of these three signed number representation method. So if it is just asking for what is the 2's complement representation of a particular number, then the sign will not change. If it is negative 3, then after 2's complement representation, this will also be negative 3. And if it is positive 3, then the 2's complement representation also going to be positive 3. Now if it is initially plus 3 and we are being asked what is 2's complement of plus 3, then we need to do 2's complement operation on plus 3. And what happens? If we apply 2's complement operation on any signed number, then the sign of that number changes. That is, if it is initially plus, after 2's complement operation it becomes minus, and the vice versa is also true. So we have made the arrow directional. So here in this 2, the most crucial thing we must need to see that when it is asking for 2's complement representation, then actually it is not asking to do anything, just to represent whatever the number given in 2's complement. And representation in 2's complement does not changes the sign. It is actually the main representation of that particular number. If it is a negative number, then we need to represent it in 2's complement method, in 2's complement representation. And if it is asking for 2's complement operation, then we need to change the sign. Now we see what is the mechanism by which 2's complement operation is done, and that mechanism will help to represent. When we are going to represent any negative number, it will help, because representing a positive number is very simple. If we want to represent plus 3 in 2's complement, it is just the binary representation of 3 with an extra bit for the sign. That is, if it is a 4-bit representation, it is going to be like this. One just the magnitude of 3 in binary, simple binary, and the most significant bit, this 0, signifies positive sign. But if we want to represent minus 3 in 2's complement representation, then we need to learn the mechanism by which a number from positive to negative is converted by using 2's complement operation. So in this case, initially it is plus 3, that is 0 0 1 1. Now after 2's complement operation, it is going to be negative 3. Now let us do the mechanism. So first of all, what we will do, we will make it 1's complement representation. We will apply first the 1's complement operation on this. So if we apply 1's complement operation, what happens? Each and every bit of this representation is complemented. So after 1's complement operation, it becomes like this, including the sign bit. All of this bit we have just complemented. Now to get the 2's complement representation, then what we will add 1 with this, and after the addition operation we will get the 2's complement representation. So here we get the number. So let us see what is happening here. So initially this number was the 2's complement representation of plus 3, but here after 2's complement operation we are going to get minus 3. So what is the 2's complement representation of minus 3? So for getting that representation, we need to 2's complement plus 3. So here in this mechanism, we are applying 2's complement operation on this number, that is plus 3. Then initially what we have done, we have calculated its ones complement by complementing each bit, and then we have added +1 with that, and whatever we get, that is the 2's complement of +3, that is 2's complement representation of -3. Very crucial point here, this is the 2's complement of +3, means actually this is -3, and this is the 2's complement representation of -3. If we add the word representation, then we are not going to change anything, just we are going to represent it. But if we are asked what is the 2's complement of +3, then that is actually representation of -3. So this is going to be like this. So 2's complement representation of -3 is 1101. Now let us revise it once more. Let us see these two questions. What is 2's complement representation of +3, and what is 2's complement of -3? Both of these questions are same. That is, answer is going to be the 2's complement representation of +3. That is, if in the second question, if it is asking for what is 2's complement of -3, so what is 2's complement of -3? That is +3. So we need to, in our answer, we need to represent +3 in 2's complement representation, and here it is directly asking for the representation. Okay, so this is the main crucial thing. Now if it is asking for what is 2's complement representation of -3, then actually it is asking for what is 2's complement of +3. This 2's complement is +3 is going to be the representation of -3. So now if it is a positive number representation, then it is very easy. Just we are going to write its binary equivalent and adding a sign bit there. And if it is asking for representation of a negative number, then actually we cannot write the negative number directly. We need to just convert it from the positive one. So in that case, the 2's complement operation mechanism what we have seen here is need to apply. That is, for in this case, if we write we want to write this answer for these two questions, actually both of these questions are same. If we want to write this answer, then we need to first we will write +3 here like this, and then we will convert it to 2's complement representation. That is, answer will be 1101 for this case. That is, when we are going to represent a negative number, then the 2's complement operation is necessary. That is to calculate the value of the negative number representation from the positive one.